What is the Reynolds number in convection heat transfer? Imagine watching a stream flow over a rock and wondering what makes the water move smoothly or swirl chaotically. That's where the Reynolds number comes into play. It is a simple way to tell if the flow of a fluid is calm or turbulent. In convection heat transfer, it helps us understand how heat moves from a surface to a fluid or vice versa. The Reynolds number is a ratio that compares the forces pushing the fluid forward to the forces resisting that motion. These forces are called inertial forces and viscous forces. Inertial forces come from the fluid's mass and speed, while viscous forces are due to the fluid's internal friction. When the inertial forces are much stronger, the flow tends to be chaotic and turbulent. When viscous forces dominate, the flow is smooth and steady, called laminar flow. To find the Reynolds number, you take the fluid's density, multiply it by the characteristic velocity, and then multiply that by a characteristic length, like the diameter of a pipe or the length of a flat plate. Then, you divide that by the fluid's dynamic viscosity, which measures how thick or sticky the fluid is. The formula looks like this. Rho equals the fluid's density times the velocity times the length, divided by the viscosity. Alternatively, you can use the kinematic viscosity, which is the viscosity divided by the density, and then the formula becomes the velocity times the length divided by the kinematic viscosity. In convection, the Reynolds number tells us how effectively heat is transferred. When the number is low, the flow is laminar, and heat moves steadily through the fluid. When it is high, the flow becomes turbulent, mixing the fluid more thoroughly and speeding up heat transfer. For example, over a flat surface, if the Reynolds number is below about 500,000, the flow stays smooth. If it goes above that, turbulence starts, and heat transfer becomes much more efficient. Engineers use the Reynolds number to predict how fluids will behave in systems like cooling electronic parts, heating liquids in pipes, or airflow over airplane wings. It helps them choose the right models and calculations to estimate heat transfer rates accurately. So, in simple terms, the Reynolds number is a key number that links how a fluid moves to how heat is transferred within it. It's a handy tool to understand and control heat transfer processes in many practical situations.